Hey guys, welcome back to my YouTube channel. So in this lecture, we are going to start our discussion on the digital electronics, which is continuing to the data representation. So as we know guys, the digital electronics majorly focusing on the data that to be handled in CPUs or other kind of digital devices. So how the data can be represented is one of the very important term that we have to take into account. So that we are going to see today. So there is four kind of data representation that will follow. The first thing is unsigned magnitude. So unsigned magnitude representation. So which is one of the very simple understanding. So there is four thing. So as we go one by one. So this is unsigned magnitude. So in this unsigned magnitude, we represent only positive numbers. So this is some traditional methodology that they followed long back. So only positive numbers only. Okay. So if there is n bit, if n bits are there, so the range can be varied from 0 to 2 power n minus 1. So this is what the representation that we can follow. If 4 bit is there means we can represent up to 0 to 2 power 4 is 16, 16 minus 1 is 15. So up to 15 bits we can represent in the unsigned magnitude. So how this is normal representation, like how we represent the digital, the binary numbers, how we represent. So that is what the system. So the demerit is that the negative numbers cannot be represented in the system. So in order to make that perfect, they bring the signed complement, signed magnitude representation. So in this one, we can represent both positive and negative numbers. So for this only, the MSB is dedicated to sign. The MSB is dedicated to sign. Means the left hand side last bit is dedicated to sign bit. Okay. So if sign 0 means it is positive number. If it is sign 1 means it is negative number. So that is what the terminology that they followed previously. So with n bit, so if n bit number is given, we can represent up to negative 2 power n minus 1, 1 to 2 power n minus 1, 1. Okay, so this is what the range that we can represent. So let's take a table. So how we can represent the signed magnitude and normal magnitude. So this is the table where this is the sign bit and this is magnitude. Okay, so how we can represent it? This is for positive, that is for negative. So if we take a 4-bit number means it is normal. For 0, it is 0. The sign bit can be, if it is, can be 1 or minus 1. If it is minus 1, this will be called as minus 0. If it is positive, it is called as positive 0. So that is what the difference. Okay. So if it is 1, 0, 0, 1 and the sign bit is 1, we can call this as minus 1. And if it is 0, 0, 1 and the sign bit is 0, then we call as positive 1. So similarly, if we follow this terminology up to last number, that is 1, 1, 1. If sign bit is 1, then that is minus 7. If the sign bit is 0, then that is positive. Okay. So this is what the representation that is followed in sign magnitude representation. But one of the demerit is that 0 has two representation, that is positive 0 and minus 0. So which will confuse the data representation scheme. So 1, 0, 0, 0. So this is one of disadvantage. So that eventually they vanished the system. The system is not in any of the uses now. Okay. So 4-bit number is coming. The range can be from minus 7 to 7. Okay. So that is what the range. So because of this disadvantage, they removed the system. This is not used. Okay. So another one disadvantage is also, for an example, if it is on 4-bit, if let me take a new page. If n is equal to 4-bit, positive 7 can be represented as 0, 1, 1. Minus 7 can be represented as 1, 1, 1. If it is n is equal to 8-bit, the positive 7 can be represented the same thing as 0, 0, 0, 0, 1, 1, 1. Because this one is representing positive. Here minus 7 can be represented in 8-bit as 1, 0, 0, 0, 0, 1, 1. This is for sign bit. Here you see, for the extension of the bit from this to this, here we can directly extend all the zeros. But here if you see, the extension is not possible. because you need to add zeros in between the number. So this is also another one disadvantage. So this is second disadvantage. The extending is not possible. The extending the range is difficult. We need to insert zeros. So the extending from 4 bit to 8 bit is difficulty. Extending is difficulty. Right. So then the master came big. That is signed 1's complement representation, which is third one. So which is signed 1's complement representation. So we know 1's complement, how to take 1's complement for all the radix digit. So here it is including signed representation. So please understand carefully in order to get into same phase. So in signed 1's complement representation, if the number is positive, it is represented as it is. So positive number, it is as it is. Positive number can be represented as it is. So there is no change. If number is negative, then it is represented in 1's complement. I already say the complement is nothing but the minus to positive, the conversion. So that is why the negative numbers are taken complement. Okay. So let's take an example how we can represent the things. So here it is for negative number, here it is for positive number. So 0, 0, 0, we take 4 bit. So 0, 0, 0, 1, 0, 0, 1, 0. So this is positive 0, this is positive 1, this is positive 2, up to we can represent up to 7. So which is positive 7, which is as like all the previous system. So here if you see, the negative can be represented. If negative means we have to take complement for all things. So 1, 1, 1. So this is minus 0. So if we take 1, 1, 1, 0, then that is minus 1. There's a complement of this. This is 1's complement. This is 1's complement. So if we take this one, this is 1, 1, 0, 1. So this is minus 2. Right? So if it is follow, then 1, 0, 0. So this is minus 7. So here if you see, there is two disadvantages. The one thing is that 0 has two values. So 0 has two values. So positive zeros are represented as 0, 0, 0, 0, and minus 0 are represented as exact opposite 1, 1, 1. So this is one disadvantage. And the range is from, if we are using the 4 bit, if n is equal to 4, then the range will follow from minus 2 power n minus 1 to 1, 2 power n minus 1 to 1, the same thing. So means minus 7 to plus 7 we can represent. But here the disadvantage will continue. The first disadvantage, the 0 has two representation. So if n is equal to 4 bits, then the positive 7 can be represented as 0, 1, 1, and minus 7 will be represented as 1, 0, 0. Just a complement of this one, right? So if n is equal to 8, if I have to represent this as an 8 bit, then positive 7 can be represented as 8, 0, 0, 0, 0, 1, 1, 1. Then minus 7 is just a 1's complement of this, right? This is 1, 1, 1, and 1, 0, 0, 0. If you see, the sign bit is just an extension. So the second disadvantage of the signed magnitude representation is solved here. So there is only one disadvantage, that is 0 has two representation. So one thing, extending is now easy. So extending from 4 bit to 8 bit is now pretty much easy. So that we have solved. But there is two representation for 0, that is one disadvantage. So then this is the another one improvement that they gave. So there is nothing but signed 2's complement representation. This is the last and final one. So which is signed 2's complement representation. So here the same thing. In the signed 2's complement representation, the positive number will be represented as it is. The negative numbers are represented in 2's complement. Okay. So let's see how this is solving our disadvantage of 2 representation in zeros. So if we take the negative number here and positive numbers here, so 0 can be represented as it is, so which is positive 0. So if we take 1's complement, then that will be 1, 1, 1, 1, 1. So that is the normal thing. And then if we add 1 to that, then that will be become as thing. So for an example, if we take 1's complement of this one, this will be 1 1 1. Then if we add 1 here, then it will be 0 0 0 and then 1. So if we think the 1 is extra bit, so that can be neglected here. So the 0 has same representation. So even the positive 0 is same as well as negative 0 has the same representation. So the disadvantage is override here. Then the minus 1 how it can be represented, let's see. So the 0 0 0 1. So here see the minus 0 also has the same 0 0 0. Okay. So this is positive 1. So if we take 1's complement for this 1 1 1 0 and add 1, it will be 1 1 1. So the minus 1 can be represented as 1 1 1 1. So this is the minus 1. Okay. So 2 can be represented as 0 0 1 0. We take 1's complement for this one. This is 1 1 0 1. If we add 1 to that, then 0 1 0 0. So 1 1, sorry, here it is 1 1 1 1. Okay. So 1 1 0 1. So this is the representation of 2. So if it is continuing like this, then 7 can be represented like this, which is positive 7. And the complement for this is 1 0 0 0. And if we add 1 to that, then 0 0 1. So this is the representation of 7. And then even if you see here, another 1 bit can also be added here. So if we add 1 here, then we also can represent 1 0 0 0. So which is nothing but 8 minus 8. Okay. So the range is extending from here. So here you see the negative as the minus 0 also have the same thing. So extra 1 bit can be represented here. Like the plus 8 can't be represented here, but the range of minus 8 can be represented here. So if you see the first disadvantage that 0 has 2 representation is neglected. So if you see the 0 has same, positive 0 and negative 0 has same. So negative 0 has same value. So that is eliminated here. So then next advantage is that the range. If we take the range is from minus 8 to positive 7 as we see in the graph. So this is because 2 power n minus 1 to 2 power n minus 1 to 1. So this is what the thing that we can take into picture. Why this is because is the 0 has same representation. So there is one extra number can be represented, because here we can represent up to 7, because we have the streamline of 3 bits can represent up to 8 numbers, right? So that thing only we are taking into advantage of here. So the minus 8 can also be represented, because the first bit we mostly consider for sign, because as we from the signed complement, the first bit we won't take into picture. The last 3 bit only we take into picture. So 2 power 3, which will be mostly from 8. So the positive numbers has 0 to 7. So the 8 range is filled. But in negative, because of 0 didn't have the value, so we have minus 1 to minus 7 only. So minus 0 is also picked in minus 0. So this can be included up to minus 8. So that's why the range we are extending to minus 8 to minus 7. So here we are getting one extra number also. So one extra number representation is also possible in this one. So one advantage is clear. So let now see how the extending is possible or not. So if n is equal to 4 bits, then positive 7 can be represented as 0 1 1 1. Then the minus 7 can be represented as the 2's complement of 1 0 0 1. So if n is equal to 8, then positive 7, which is equal to 0 0 0 0 1 1, just the same extension. Then minus 7 can be represented as the minus 7 can be represented as 1 1 1 0 0 1. So this is will also be I think I missed 1. So this is also same extension like this one. So this is as like same extension. If we extend the zeros, it will be able to get 8 bit. If we extend this one, we are able to get for 8 bit. So extending also possible here. So the 2's complement is one of the ideal one that we can use, because it solves both the thing. So some guys may have doubt why the minus 8 is coming here. That is because of this one. As minus 0 also coming in the same representation of positive 0, it can able to represent one extra bit number here, because we have the constraint of only 3 bits, because the first number we will not include, because we are representing for negative also, right? So that thing we will not include. So as the thing, what the thing is that it is 4 bit, right? So it can represent 2 power 4 minus 1, means 50 numbers it can represent. In previous thing, 0 itself has 2 representation, so that only we can able to represent up to minus 7 to 7, means the range is 0 has 2 and here 7 plus 7. So that range, adding to that, we can able to up to I think 16 digit including 0. So because of that representation, we can only able to represent up to 16 range, which is from -7 to 7. But in 2's complement, the 0 has only one representation, that is both positive and negative has same value. So we are extending the one thing in negative. So that is why this range is happening. So this is one of the very important range that you guys have to remember. So I hope you guys able to understand all the 4 types of complements. So from the comparing all the thing, the 2's complement is the best. 2's signed 2's complement, sorry. So signed 2's complement is best. In all our laptops and all our mobile phones, everything uses this 2 signs complement representation only. So in the next class, I will be letting you know what's very much important of 2 signed 2 complement representation and how that are used in our real time to add and subtract the numbers. I will be letting you know how that can be done in the next classes. So I hope you guys able to understand the advantages of signed 2's complement thing. The thing is that positive 0 and negative 0 has the same representation. So negative 0 has same representation, and extending is also possible here. And another one thing is that extra one number can also be represented here. So there is extra 1 bit representation, extra one number representation, which is also possible here. So these are some advantages that we are preferring signed 2's complement in our day-to-day modern CPU and all the data representation. It will follows the 2 signed 2 complement representation. Okay guys, stay tuned. So in the next lecture, I will be showing the 2's complement arithmetic operation and 1's complement arithmetic operations. So it's all very much important. That will be helpful for you guys in all the college placements and as well as your college examination and as well as GATE examinations, those stuffs. So stay tuned guys. So let's see in the next lectures. Thank you.